AI agents are amazing, but what if they truly had a million proven skills at their fingertips? This new paper introduces a massive, verified library that finally makes them reliable and secure. Let's get into it. Let's start with a featured paper, SkillCenter, a large-scale, source-grounded skill library for autonomous AI agents, by Tianming Xia and Yushuan Dong from Stony Brook University. This is a landmark resource paper that provides a massive, high-quality, and source-grounded skill library that will be a critical enabling technology for the entire AI agent development community. Here's a full breakdown.
Let's start on the left with the data sources, where the process begins by gathering information from a wide range of places. This includes academic papers, code from GitHub and Stack Overflow, and content from the wider web, all of which are fed into the collection funnel. Feeding into the central pipeline, all that collected data must first pass through the quality gate, also known as skill gate. This is a crucial filtering step to ensure only the most reliable and useful information moves forward. Next, the high-quality data enters the skill generation stage. Here, the system transforms the unstructured information into standardized, usable skills, which you can see emerging as these well-formed puzzle pieces. A core principle of this multi-stage pipeline is ensuring every single skill is traceable back to its origin. This process guarantees that each claim is grounded in the original source documents, creating a verifiable and trustworthy library. Finally, in the output and application section on the right, the curated skills are published for use. They are made available as a structured SQLite FTS5 database, creating an offline searchable library ready to power AI agents. This table details the distribution of skills across various categories and sources, showing the number of skills and an associated score for each domain. However, it does not provide a direct comparison of this method's performance against prior work or baselines.
Up next, our second paper out of 10, Unicode tag block concealment of Tool-Metadata payloads in the Model Context Protocol, an approval view fidelity gap across 3 independent server implementations by Mohammad Reza Rashidi from Department of Computer Science, AI and Media Analysis Lab, Berlin. This is a landmark security paper that discovers and demonstrates a subtle, high-impact vulnerability in the fundamental protocol used by most AI agents to interact with tools. Let's break down its key contributions.
We start with the Model Context Protocol, where a server response from a tool/list handshake is parsed into 5 independent metadata surfaces. This is where the fidelity gap emerges. An attacker can perform attacker control payload, encoding to create a payload that merges with the tool's normal metadata. Feeding into this, the concealment is achieved using Unicode's tag block to create the encoded payload tokens. This means that when the human review render prepares the view for an operator, the malicious payload is invisible, even though it's present in the data stream that goes to the model. Next, to prove this is a real-world threat, a proof-of-concept system was built that speaks the actual protocol, starting with an MCP tool object. This object is sent to the server's tools/list handshake endpoint, demonstrating how a malicious client can engage with a real server to initiate the exploit. The system then demonstrates a range of concrete attacks across 5 different metadata surfaces parsed from the server's response. For example, one attack is metadata injection, which targets the tool's description field, while others target the schema, tool name, and even error messages. Finally, to confirm the vulnerability is widespread, the entire attack catalog was validated against multiple, independently developed server libraries. While this diagram shows a single logical flow, the research confirmed this isn't a one-off bug, but a systemic issue. The Unicode tag block concealment technique, T7, successfully reaches the model context and evades baseline sanitizers, a feat shared with techniques T4, T8, and T6. However, T7 uniquely succeeds in evading human review, a critical step that all other techniques fail to bypass, though none of the evaluated methods force reapproval.
Up next, our third paper out of 10, RoboSnap, one-shot real-to-sim scene generation for generalizable robot learning and evaluation by Xujie Zhang and Chenhua Shin from Shanghai AI Laboratory. The work presents a potentially transformative real-to-sim framework that generates physically interactive and visually faithful simulation environments from a single RGB image, drastically lowering a major barrier in robotics. Let's break down its key contributions.
Let's start with the overall RoboSnap framework, which is the entire pipeline you see here. It's designed to take a single RGB image and efficiently convert it into a complete, interactive simulation. Feeding into this, the system uses a layered scene design, which is the core of this first section. It intelligently separates the interactive objects identified using SAM 3D from the static background, which is then painted to create a full 3D world model. Next, for the interactive objects, the system performs a crucial simulation-ready refinement. This two-step process uses a physics phase and an SDF phase to adjust the objects until they settle into a physically stable state, as shown in the before and after comparison. To ensure the scene looks realistic from any angle, a 3D Gaussian splatting technique is used for the background. This process results in a 3D world model, which faithfully preserves the visual appearance of the original environment. Finally, to help advance research in this area, the authors introduced the DROIDSIM dataset. While the dataset itself isn't pictured, its purpose is demonstrated in the data generation panel, where these simulated scenes are used to create vast amounts of training data for robots. RoboSnap, ours, demonstrates substantially superior performance compared to all other methods, including SAM 3D and ROLA, across all metrics like falling, collision, and various mean squared errors. It achieves significantly lower error rates, for example, reducing the trans MSE to 0.0022, which is orders of magnitude better than the next best approach.
Up next, our fourth paper out of 10, the Oracle's Gambit, a game-theoretic framework for responsible AI released by Christoph R. Landolt and Mario Fritz from CISPA Helmholtz Center for Information Security. This paper introduces a sophisticated and novel game-theoretic framework to bring formal rigor to the critical, high-stakes, and often informal debate around responsible AI model releases. Let's break down its key contributions.
Let's start at the top with the overall structure, which is framed as an outer Stackelberg game. Here, the Frontier AI Laboratory acts as the leader, making the first strategic move in this interaction. The lab's key action is to commit to a release policy, which isn't just a single decision. This policy dynamically parameterizes the capabilities of both defenders and adversaries over time, as shown by cap_F_T and cap_T. Feeding into the next stage, the lab's policy sets the rules for an inner zero-sum stochastic game. This models the downstream contest between the followers, the defenders developing patches, and the adversaries developing attacks. Next, the outcome of that contest is evaluated through backward induction to determine the welfare of the defender. This allows us to quantify the benefit of creating a protective capability gap for the good actors in the ecosystem. Ultimately, all of this feeds back to the lab, allowing it to find the optimal release policy, which is the best sequence of access. This is calculated as the Stackelberg equilibrium, where the lab chooses the policy that maximizes its own payoff. The framework evaluates different release transitions, showing that they can avert between 14% and 41% of attacks. Additionally, the change in defender utility, delta UDEF, is consistently positive across all transitions, indicating an improved defense posture with a peak of plus 4.06.
Up next, our fifth paper out of 10, GemNav, Discrete-Token Visual Robot Navigation using a Multimodal Large Language Model by Peter Boehm and Payman Mogadam from Cyro Technology, Australia. GemNav delivers a paradigm-challenging result by demonstrating that a frozen, general-purpose multimodal model can be adapted for a complex robotics task with surprisingly minimal and efficient fine-tuning. Let's break down its key contributions.
Here's our overall architecture, GemNav, which is built around the Gemma 4 multimodal large language model. Notice that most of the model, including the Gemma 4 vision encoders and the core language model, is frozen, which is key to our efficient adaptation approach. To adapt this frozen model for navigation, we apply low-rank adaptation, or LoRa, to the transformer blocks. Crucially, this tuning is only on the language tower's projection layers, like the QProj and VProj, keeping the rest of the system lightweight. Next, let's look at how the model outputs actions. It generates a sequence of discrete tokens, starting with a special BotTroj token. This sequence includes not just waypoint tokens like tau1 and tau2, but also categorical signals like EAT-Troj, all from a single vocabulary. Finally, to improve training, we introduce a soft decoding step for the predicted waypoints. This allows us to check if the first predicted waypoint, tau1, has reached the goal, and if not, we continue decoding, which helps the model learn the metric structure of the space. GemNav, ours, achieves a perfect success rate of 5/0/0 across all environments, significantly outperforming the OmniVLA baseline, which consistently fails. While generally slower and sometimes covering more distance, GemNav demonstrates substantially lower deviation, indicating more precise navigation than both OmniVLA and human performance.
Up next, our sixth paper out of 10, from closed-loop optimization to open decision-making, coupled digital twins for predictive and autonomous microscopy by Yu Liu and Sergey V. Kalinin from Department of Materials Science and Engineering, University of Tennessee, Knoxville. It introduces a powerful and generalizable conceptual framework for autonomous experimentation by creating coupled, digital twins of the sample and the instrument, enabling predictive forecasting and sophisticated decision-making. Let's break down its key contributions.
Let's start with the overall architecture in Panel A. We have two key components, the AFM digital twin and the sample digital twin, which are combined to generate predictions about the experiment. Feeding into this, the sample digital twin is specifically designed to model the sample's response and its evolving state. This is crucial for understanding how the material itself will behave under the microscope's probe. On the other side, we have the AFM digital twin, which provides a deterministic model of the instrument itself. It captures the scanner's behavior, the cantilever dynamics, and the instrument's physical operating limits. Now, how do we keep these models accurate? As shown in Panel B, after an action, we compare the predicted outcome with the observed outcome and use this information to update the twins, correcting for errors and refining future predictions. Finally, to make the system even smarter, we perform a deeper analysis of any remaining errors between prediction and reality. This helps us understand where our models might be incomplete, guiding future improvements to the underlying physics. The hybrid method, along with the pure data-driven approach, substantially outperforms the pure physics method in terms of line shape error, reducing it from 48 nanometers to 20 nanometers. While the pure physics method shows the lowest scalar quality error, the pure data-driven method offers the best overall balance, achieving low line shape error with a slightly better scalar quality error than the hybrid method.
Up next, our seventh paper out of 10, Bridging Physical Reasoning and Task Generalization via Visual Action Outcome Reasoning Alignment by Hanjun Ko and Yucheng Frank Wang from National Taiwan University. This work introduces a novel and elegant reward mechanism that directly targets the core failure modes of VLMs in robotics, representing a significant step toward building physically grounded and generalizable agents. Let's break down its key contributions.
First, our physical reasoning VLM generates a detailed reasoning text, R, breaking down its understanding of the scene and the required steps. This reasoning is then compared with the environmental outcome, O, to calculate our visual alignment reward, which is composed of the grounding reward, collision reward, and placement reward. Next, to ground this reasoning in the agent's actual performance, we introduce the gated visual action alignment reward. This is done by taking the visual alignment reward and multiplying it by the succeed probability estimated by our expert. Feeding into that calculation, we use a pre-trained DQN expert to achieve a smooth, dense reward. This expert provides a succeed probability for the chosen action, which helps to shape the final reward signal for our agent. The proposed method, plus EG plus VAURA, substantially outperforms its base model, Quinn 3VL, 8B, SFT, and other open-source baselines across all paths it came metrics and testing sets. It also achieves competitive performance with closed-source APIs like Gemini 3.1 Pro, notably surpassing it on testing set 1, with a pass at 1 of 0.
Up next, our eighth paper out of 10, StateFuse, Deterministic Conflict-Preserving Memory for Multi-Agent Systems by Sergey Volkov and Yi Luo from the University of Hong Kong. StateFuse is a rigorous and foundational systems paper that correctly identifies and solves the critical, difficult problem of managing state and disagreement in multi-agent systems. Let's break down its key contributions.
To begin, let's trace the core memory contract. After an agent adds data via the memory API, it's processed into an op log and then used to materialize the memory state, which represents the system's current understanding. Feeding into that state is the agent-facing layer, where every action is recorded in the op log as an immutable operation. This creates a permanent and auditable history that cannot be rewritten. Next, the system doesn't hide disagreements. It surfaces them explicitly. After the state is materialized, it goes through conflict set detection to identify any contradictory claims within the data. Finally, resolution happens at read time, ensuring the base log remains unchanged. The resolver's decisions result in a final projection, which is a consistent, selected view of the claims plus an audit trail. The StateFuse methods achieve perfect conflict recall in the official benchmark and, along with the raw log, demonstrate 100% post-verify success with zero false confidence in a uniform verification agent loop, performing on par with the Oracle. While StateFuse variants show a lower final accuracy of 64.9% compared to the 97.5% of.
Up next, our 9th paper out of 10, Escaping the Procrustean Bed, Groupwise Orthogonal Connectors for Audio-Language Models by Ho-Lam Chung and Hung-Yi Lee from Graduate Institute of Communication Engineering, National Taiwan University. The paper provides an excellent diagnosis of representation collapse in audio-language connectors and offers a clean, effective architectural solution that is likely to be widely adopted. Let's break down its key contributions.
Our model, ArXiv STA, first takes the output from the audio encoder and feeds it into several distinct attention groups, shown here as G1 through G8. This foundational step splits the audio representation into independent parts. Next, the crucial step is applying a groupwise orthogonality constraint between these attention groups. This mechanism actively forces the outputs from each group to be dissimilar, preventing the representations from becoming redundant. ORCA substantially outperforms the DESTA 2.5 Audio 4B baseline in the control comparison, achieving significantly higher scores across all Sakura reasoning metrics, including 80.5 for average S and 75.2 for average M. Compared to other reference systems, ORCA demonstrates strong performance, particularly in multi-turn reasoning, where it achieves the highest average score of 75.2.
Up next, our 10th paper out of 10. Broken ergodicity and the violation of the Fluctuation-Dissipation theorem lead to generalization beyond overfitting in machine learning by Chan Lee and Nigel Goldenfeld from University of California, San Diego. This work provides a profound theoretical breakthrough by connecting the mysterious double descent generalization phenomenon in neural networks to fundamental concepts from statistical physics, namely broken ergodicity. Let's break down its key contributions.
Here in panel A, we see the classic double descent curve, with a generalization error, shown by the black dots, peaks when the number of parameters matches the number of data points. Our theoretical predictions from dynamical mean field theory, or DMFT, are the solid lines, and they perfectly capture this simulated behavior. Feeding into this, our theory allows us to precisely calculate the scaling functions and critical exponents that describe this phase transition. These formulas, shown in the legend, define the exact shape of the error curve as it diverges at the critical point. Next, we find this phase transition is marked by a fundamental breakdown of the fluctuation-dissipation theorem. Looking at the dynamics in panel B, for the critical case of alpha equals 1.0, shown in red, the generalization error continuously increases with training iterations, indicating the system never reaches a stable equilibrium. Finally, this analysis reveals a striking parallel to physics, as the derived response function for our system has the same mathematical form as the simple London model. This draws a direct analogy between the double descent phenomenon and the phase transitions seen in superconductors. The DMFT method consistently achieves lower generalization error compared to SGED across various noise and gamma conditions, particularly at higher epochs. For instance, when alpha is 1.0, DMFT maintains a stable or decreasing error, while SGED exhibits significant overfitting with its generalization error substantially increasing after initial training.
Those were the top papers. Now, let's zoom out. ArXiv received 1,160 new computer science papers across 71 subfields over this window. Here are the trending areas shaping the field. Zooming out, today's research really highlights AI's practical impact, from securing wireless networks to shaping education governance. It's clear AI is tackling real-world complexities. Let's take a quick look at each.
Trend 1 of 10, securing and optimizing wireless networks. This trend explores advanced techniques for enhancing the security and optimizing the performance of diverse wireless communication networks. This cluster covers 50 papers. Representative work includes contrastive predictive coding with compression for enhanced channel state feedback in wireless networks, Grover-based PLS, AUD, and beamforming with artificial noise in CDNOMA, and towards quantum network performance metrics, challenges, and demonstration. Trend 2 of 10, innovating software development and analysis. This trend explores novel methods, tools, and analyses to enhance the efficiency, quality, and understanding of software development processes. This cluster covers 133 papers. Representative work includes measuring the invisible, evaluating the impact of public funding on open-source software, bridging stakeholder and product requirements, an empirical study of requirement engineering in the automotive industry, and INV Weaver, deductive feedback for invariant synthesis in interacting loop programs. Trend 3 of 10, intelligent robot motion and perception. Robots utilize advanced perception and learning techniques for intelligent, efficient, and robust motion planning and execution. This cluster covers 127 papers. Representative work includes learning 4D geometric priors for inference-efficient world action models, quaternion averaging-based adaptive complementary filter for pedestrian dead reckoning with a foot-mounted HRS, and efficient transfer learning of robot dynamic models using morphological similarity. Trend 4 of 10, extracting insights with Advanced NLP. Leveraging sophisticated NLP techniques, including large language models, to extract actionable insights and understand complex information from diverse textual data. This cluster covers 168 papers. Representative work includes scientific code search at scale, a multi-domain dataset and benchmark, retrieval over reasoning, a cost-controlled benchmark of language models for energy retrofit recommendation, and linking hadith narrator identities across heterogeneous Arabic biographical databases, a multi-signal entity resolution pipeline. Trend 5 of 10, solving complex systems mathematically. This trend applies advanced mathematical methods, algorithms, and theories to analyze, model, and solve problems within diverse complex systems. This cluster covers 71 papers. Representative work includes the matrix toolbox, component-wise accurate algorithms for M matrices with triplet representation, towards lattice surgery compilation for the color code using pipe diagrams, and input to state stability implications in contraction theory. Trend 6 of 10, robustness in machine learning models. This trend explores methods and analyses to enhance machine learning model reliability, stability, and performance against various data and environmental challenges. This cluster covers 122 papers. Representative work includes to retain or to adapt, generalizing continual learning, on the linear convergence of Bregman proximal gradient methods with applications to Kullback-Leibler regression, and the granularity paradox, how temporal disaggregation inflates in-sample fit and compounds out-of-sample error. Trend 7 of 10, efficient computer vision and rendering. Advancing computer vision and rendering through efficient algorithms, hardware, and adaptive models for diverse applications. This cluster covers 190 papers. Representative work includes Geospline, on-the-fly visual explanations for weather foundation models, cross-contextual vision language adaptation with LoRa for personalized severe adverse event detection in clinical wound monitoring, and Bitfair, a 12nm bit serial CNN accelerator with learnable early termination and adaptive bit ordering for ultra-low power XR vision. Trend 8 of 10, AI agents and education governance. Investigating AI agents application in education and the governance mechanisms ensuring their responsible operation. This cluster covers 136 papers. Representative work includes why does AI unlock new possibilities in STEM education? A bibliometric analysis of trends and future agenda. Automated recommendation of programming learning content using pattern-based knowledge components and AI tools in Arab University English classrooms. Looking back and forward. Trend 9 of 10. AI unlocks complex system secrets. AI and machine learning techniques are employed to model, analyze, and gain insights into intricate systems across diverse scientific and engineering domains. This cluster covers 76 papers. Representative work includes empirical minimal realization compression of deep neural networks via controllability observability tests, forward-looking stress testing under macro scenarios, stable SVR estimation using a hybrid GPRHS framework with SACS, and physics-regularized machine learning for proprioceptive vehicle localization using onboard sensors. Trend 10 of 10, unraveling graph, sequence properties, limits. This trend explores graph structures, sequence characteristics, and their theoretical bounds or computational limits across diverse domains. This cluster covers 87 papers. Representative work includes height functions on the m times n Miura-Ori flip graph, degree sequence, and diameter. One construction for the Miura-Ori flip graph degree sequence, and on the group randomness of 0 to 1 real sequences from binary linear codes.
That's all for today's ArXiv Computer Science Daily. If you found this helpful, please leave a comment, and subscribe for daily paper summaries. See you tomorrow. Thank you to ArXiv for use of its open access interoperability.